So we're at the main point of this chapter, and that's to show whether arguments are valid or invalid. Now, when we talk about a valid argument, we're not saying that the conclusion is true. What we're saying is the form of the argument makes sense. An argument is a conditional statement if P then Q, where the P portion, the first portion, and it doesn't have to be one statement, it could be many statements. That's what we call our premises. Those are the reasons why we support our then or our Q portion, which is our conclusion. In an argument, you may have many premises, not just one statement. It could be many statements. But you always just have one conclusion for each argument. A valid argument means a true conclusion follows from premises that are assumed to be true. So the reason why I have true in quotations is because in reality the conclusion may be false. All we're saying that is, and this is the important part, that if we assume our premises are true, then the conclusion has to follow from those premises. In reality, maybe the premises are not true, but if we assume the reasons are true, then the conclusion has to follow. An invalid argument is just an argument that's not valid. Oftentimes it's called a fallacy. A sound argument is a special type of valid argument. It's actually a valid argument with true premises, so we can actually prove that the premises are true. So oftentimes, and this will happen, I don't know if anybody's been on a jury trial, you'll have your defense attorney, you'll have the prosecuting attorney, and they're arguing their case. Their argument are their premises, and oftentimes it's difficult for them to prove those premises are true. So their job is to make the jury believe the premises are true. So if they can sway the jury to believe their premises are true, then the jury has to come up with the conclusion, whether it be guilty or not guilty, depending on which attorney is the best. So oftentimes you'll find that the rich get lighter sentences or they don't pay as much for a crime, and that's because they can afford an attorney that's really good at persuading a jury to believe their premises. So let's talk about valid or invalid. We're going to look at these three examples. The first one, it's an if-then statement, so it's an argument. The first part, those would be our premises, and here there's two. See the and there? All pigs are mammals, babe is a pig. Those are our premises. So if we assume those premises are true, does the conclusion babe is a mammal, does that follow from those premises? And it does. If all pigs are mammals and babe is a pig, then the conclusion babe is a mammal follows and it's valid. Let's look at the next one. We have an if then. All pigs are mammals and babe is a pig. That's our premises. Again, there's two. Then water is wet. This is an invalid argument. Premises are true, and in fact the conclusion is true as well. Water is wet, but the conclusion does not follow from those premises. So this is invalid. So again, the conclusion has to follow from the premises. Last example. All teachers are men. Jody Storm is a teacher. Jody Storm is a man. Is this a valid argument? It is. If we assume those two premises are true, all teachers are men, Jody Storm is a teacher. If we assume that those are true, then we must come to the conclusion that Jody Storm is a man. By the way, I'm not a man, I'm a woman. So the conclusion, notice, is false. However, if we assume that the premises are true, then that is the conclusion we get. Now, of course, we could see which premise is actually false. All teachers are men. That's a false premise. If I assume that it's a true premise, then the argument or the conclusion Jody Storm is a man is the only conclusion I can come up with. So are any of the above sound arguments? And that would be the first one. It's sound because the premises are true and the conclusion follows from those true premises. The other two, if an argument's invalid, can't be sound. And the last one, it's valid, but it's not sound because one of the premises is false. How do we prove that an argument is valid? In this textbook, we're going to use truth tables. If you had a previous logic course, maybe you proved it in a different way, and that's fine. However, in this book, we use truth tables. And there's going to be steps. You have to take your argument and you have to label your statements so that you can write the premises and the conclusions symbolically using P, Q, R, and so on. You're going to form your conditional statement, which would be your argument. Now, when you form your conditional statement, and this is usually where people get tripped up, remember all your premises, that's the if portion. So premise 1 and premise 2 and premise n, however many premises you have, they all have to be separated by and. Because you're saying if premise 1 is true and premise 2 is true and premise whatever is true, then we must come up with that one conclusion. So going back to an and, remember an and is true if every piece is true. So basically what we're saying here is we have a true and so on and true. So this whole thing would be true, then true. That has to happen. If we have all these truths and we get a false, then the conditional statement is false, which means the argument is invalid. So once we've come up with our conditional statement, we'll construct a truth table and we'll look at the final column. If it's all true, then the argument is valid. So this is easier to see if we look at an example. In the Menendez brothers trial, and I don't know if you remember that, these are boys that were accused of killing their parents. We have our prosecutor's argument. First premise, it's a very simple argument. If children murder their parents in cold blood, then they should be punished to the full extent of the law. Second premise, these children murdered their parents in cold blood. So the conclusion is, therefore, these children deserve to be punished to the full extent of the law. And that's basically the argument. So the first thing we want to do, and you'll see this in your MyLab, is when they give you an exercise where you're supposed to show whether an argument is valid or invalid, oftentimes they'll have the premises above a horizontal line and the conclusion below the horizontal line. So if we were to rearrange this, where you see this horizontal line, the two premises are above the horizontal line, the conclusion is below. You can think of this horizontal line as like the arrow in your conditional statement, where you're going to look at this first premise and you're going to look at the next premise and so on. I actually don't want to use the letters P and Q because that may be misleading, and you'll see why in just a bit. Below we'll have our conclusion. The word therefore is not part of the statement, these children deserve to be punished to the full extent of the law. Therefore is a conclusion word. So other conclusion words would be thus, so, however. Those are conclusion words. The symbol we use for the conclusion words is going to be these three dots. So we can replace therefore or thus or whatever conclusion word it is with these three dots. Looks like a triangle. I'm going to label my simple statements. So I'm going to look at the first premise. That was, if children murder their parents in cold blood, then they should be punished to the full extent of the law. I'm going to let P B, children murder their parents in cold blood. Okay. And they should be punished to the full extent of the law would be my Q. And you can replace they with children because it's referring back to these children. Oh, that's a terrible W. Anyway, those are my P and Q for the first premise. Let's look back at the second premise. These children murdered their parents in cold blood. Okay, so that's a single statement. And children murder their parents in cold blood. These children murdered their parents in cold blood. That's actually the same statement. Remember, things like pronouns and stuff, they don't really matter symbolically. Let's look at the conclusion. Therefore, these children deserve to be punished to the full extent of the law is the same as children should be punished to the full extent of the law. And when I am going to write this symbolically, this first premise, premise number 1, is going to be if P, then Q. Premise 2, that's going to be P. I have the line that separates my premises from my conclusion. And then my conclusion is, therefore, is the 3 dots. Everything should be in symbolic form. These children deserve to be punished to the full extent of the law is Q. So that's what it means by number 2, expressing the premises and conclusion symbolically. So now we can form our conditional statement. Remember, the conditional statement is formed by taking the first premise, which is if P, then Q, putting in and, second premise is P, right? So all our premises are separated by and. I'm going to put this whole thing in brackets. These are all our premises. So if we assume these are true, then, which would be our arrow, we have to have our conclusion Q. Probably the most difficult part. But once we have our conditional statement, then we can put this in a truth table. So we have 2 statements. We have P, we have Q. True, true, false, false. True, false, true, false. I'm going to build up. First I do P arrow Q. The conditional would be true, false, true, true. Now that I have P arrow Q, I can figure out and P. So working inside the bracket, it's an and. Where on one side I have true, the other side I have true, so it's true. And then I have false, true, which is false. True, false is false. And then true, false is false. Now let's put our whole argument in here. If P, then Q in parentheses, and P, arrow, Q. So I'm going from, remember the order really matters here. I'm going from the column of parentheses, P, arrow, Q, and P to the column Q. We're going true to true is true. False to doesn't really matter. Remember, this is a conditional statement. False to true, false to false, it's both going to be true. So false to false is true, false to true is true, false to false is true. This column is all true. And what that means is it means that this argument is valid. Valid means the argument makes sense. In example 1, we're going to determine whether the following argument is valid or invalid. Notice that this is not separated by premises and conclusion. We have to figure out which statement is the conclusion, which statements are the premises. If my teacher is here, then the classroom will be open. The classroom is open, therefore my teacher is here. Therefore is a conclusion word, so my teacher is here has to be the conclusion, which means the other statements are premises. So let's label our statements. The first premise, if my teacher is here, then the classroom will be open. So my teacher is here, that could be my P. The classroom will be open would be my Q. So I'm going to write those out. P, my teacher is here. Q, the classroom will be open. Okay, the next statement is the classroom is open, and that's the same as the classroom will be open, so that would be Q. Therefore, my teacher is here, that was P. So no new statements. I only have P and then Q. We're going to express this argument symbolically. So the first premise is if P then Q. If my teacher is here, then the classroom will be open. The next premise is the classroom is open, which is Q. Our bar for separating premise from conclusion, therefore, is the 3 dots. And then what follows is our conclusion, which is P. We need to take this argument and write it as a conditional statement. So we have the first premise, if P then Q, and always separate your premises with and. Second premise is Q. So in the brackets here, these are all of our premises separated by and. Then it will lead to our conclusion, which is P. This is the conditional statement that we need to put in our truth table. I have 2 statements, PQ. So P is true, true, false, false. Q is true, false, true, false. First premise, if P then Q, will be true, false, true, true. And now we look at if P then Q and Q. So this is an and. It's going to be true, true is true. And then false, false is false. True, true is true. False, true is false. We look at the whole argument in our last column. So if P then Q and Q, arrow conclusion is P. So remember the order matters. I'm going from if P then Q and Q to P. This is going to be true, true, which is true. False, true is true. True, false is false. And I can stop because once you have a false, the argument is invalid. Remember, the argument is valid if you only have true all the way down. Now, I could complete this. The last one would be a true, but it doesn't really matter. One false argument is invalid. Another one. So again, this is normally how you'll see your exercises in my lab. You'll see the premises above the horizontal line, conclusion below. So I'm going to use the truth table to determine whether the argument is valid or invalid. And this time I don't have the steps written down there. So you just have to remember that you want to identify your statements. P. Let's look at the first premise. I study after class or I fail. So there's 2 pieces. P could be I study after class. Q could be I fail. The next premise, I did not study after class. That's not P, so it's not a new statement. Therefore, I failed. I fail, I failed. Not a new statement. So I only have two statements, P and Q. So symbolically, this argument is I study after class, which would be P, or I fail is Q. I did not study after class would be not P. I need my line, and then my conclusion would be the three dots. I failed, I fail, same thing. That's Q. So we would write our conditional statement, parentheses, P or Q, and not P. So if we assume those are true, then if it's valid, we should get our conclusion Q. All right, that's what I'm going to put into my truth table. I have two statements, PQ. So true, true, false, false, true, false, true, false, build up. I have a P or Q. Usually I don't put parentheses around it if it's just one connective. Or would be true, 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 false. So I'm going to need the not P before I could figure out P or Q and not P. So not P would be a false, false, true, true. And this is an and statement with the P or Q and not P. So true, false is false, true, false is false, true, true is true, false, true is false. So false, false, true, false. Our conditional statement, which is our argument, would be P or Q and not P. We have our arrow, our conclusion was Q. So this is going to be true, 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 true. So remember your direction matters. We're going from P or Q and not P to that conclusion Q. All right. So we have all true. This is a valid argument. All right, let's do another example. We want to use a truth table to determine whether the argument is valid or invalid. If you reduce the amount of sugar in your diet, you increase your energy. Ooh, interesting. Notice that there's a comma. This has an implied then. So it's still an if then. We have that implied then in there. So if you reduce the amount of sugar in your diet, then you increase your energy. If you increase your energy, then you will stay awake during Math 100. Therefore, if you do not lower the amount of sugar in your diet, then you will not stay awake during Math 100. Again, we have that implied then. So these are all if-then statements. The first two are premises. I'm going to identify my P. You reduce the amount of sugar in your diet. Okay. Then you increase your energy. All right. Then the next premise says if you increase your energy, and that's already listed, that was Q, then you will stay awake during Math 100. So new statement, that's an R. Okay. And the conclusion, therefore, if you do not lower the amount of sugar in your diet, well, that's not P, so we already have that listed. Then you will not stay awake during Math 100, so that would be not R, and those are already listed, so I don't need any new letters. Our first premise is if P then Q. So we're going to put that in parentheses, and the next premise is if Q then R. Okay, so those are our two premises. I'm going to put brackets around that, an arrow to my conclusion. So my conclusion, the therefore, if not P, then not R. And this conclusion, I'm going to put parentheses around that because that's one piece. Notice I didn't even write that argument in symbolic form because I'm so used to doing this that I don't have to. However, if we did want to write this argument in symbolic form, it would be if P then Q, if Q then R, line. Therefore, not lowering sugar would be the not P. Not staying awake in Math 100 would be your not R. And that conditional statement, that long conditional statement, is what we want to put in our truth table. So I have P, Q, and R. I have 3 letters. So remember that's 4 trues and 4 false for P, 2 trues, 2 false for Q, and then alternate true false for R. I want to determine when if P then Q is true and false. So that's going to be true. True to true, true to true is true, true to false is false, true to false is false, and then false to true is true, and then it's true, true, true. If Q then R would be the next piece. That's going to be true. True to false is false. False to true is true. False, false, true. True, true, true. True, false, false. And then the rest are true. So I'm going to squish this in. Let's see if I can. So when I put these two premises together with an and, it's true, false, 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 true, false, true, and true. So let's look at our conclusion. We need a not P and we need a not R. So the not P would be false, 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 and then true, 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 true. Not R, alternate false, true. All right. So now we can figure out the conditional statement. If not P, then not R. False to false is true. False true is true. We have true, 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 false is false. True, false, true. So let's put this whole argument together, and I'm probably not going to be able to fit it, so I'm going to do part of it above. I'll do the premises above. So do we get our conclusion, which is if not P, then not R? All right, so we are going from that conclusion, or from the premise, sorry, to this conclusion. So true to true is true. False to true is true. False to true is true. False to true is true. True to false is false. And I can stop because I got a false. Now you could continue on, it should be true, false, true, but I'm not going to. I'm going to stop right there and say that this argument is invalid. We have been looking at our arguments and writing a conditional statement so that we can put it in a truth table. And then we had to figure out our truth table. So this can be a very long process. However, there are times where you don't actually have to do a truth table. And that's when we look at this table here, standard forms of arguments. This first row, these are our valid arguments. So if you had if P then Q, P, the conclusion would be Q. That's a valid argument. It's called direct reasoning. So if you translate your argument to this symbolic form, then you could just say it's valid without writing the conditional statement and without figuring out your truth table. Then we have contrapositive reasoning. If P then Q, not Q, conclusion not P, valid. Here we have the last two would be one with or, so P or Q, not P gives Q, P or Q, not Q gives P. And the other one, which is transitive reasoning, and that's what we did, similar to what we did in the last one, but it's actually invalid, so it would be the next row that I'll go over in just a sec. So if you have if P then Q, if Q then R, conclusion would be if P then R, or another valid conclusion would be if not R, then not P. So these are all valid arguments. Again, if you can get your symbolic argument to look like this, you don't have to write the conditional statement and you don't have to do a truth table. So some common invalid arguments would be if P then Q, Q, conclusion P. That's actually invalid, and we did an example of that in the beginning. If P then Q, not P, conclusion not Q, invalid. And these are two ors, P or Q, P, conclusion not Q, invalid. P or Q, Q, not P, invalid. And then the last one would be if P then Q, if Q then R, conclusion if R then P, invalid. If not P then not R, invalid. In example 4, we want to determine whether each argument is valid or invalid. So we have, if the defendant's DNA is found at the crime scene, then he will be found guilty. He was found guilty, consequently, we found evidence of its DNA at the crime scene. So this is all in words. It's not clear which is the conclusion and which are the premises. So I'm going to look for a conclusion word, and I see consequently, which I don't want to have that thick. I always do that. Consequently is a conclusion word, like therefore. So we found evidence of its DNA at the crime scene. That would be my conclusion. That must mean that remember, there's only one conclusion. So that means the other statements must be my premises. If the defendant's DNA is found at the crime scene, then, so my P could be the defendant's DNA is found at the crime scene. When I look at A, it would be if P, then Q, he will be found guilty. The next premise is he was found guilty, so that would be Q. My conclusion, therefore, or consequently, we found evidence of his DNA at the crime scene. That's the same as the defendant's DNA is found at the crime scene. So that's P. If we look up at that table, I can see that this takes the form of an invalid argument. It would be this first box here. If P then Q, Q, conclusion P. So this is invalid. It's what we call a fallacy of the converse. and I used the table. I still had to write my argument in symbolic form, but I didn't have to write my conditional statement. Let's look at B. If you exercise, your self-esteem goes up. If your self-esteem goes up, everything is wonderful. So, if you exercise, everything is wonderful. My conclusion, I have this so, that's a conclusion word. Conclusion is, if you exercise, everything is wonderful, which means the other statements are premises. Oftentimes you will find the conclusion at the end, but not necessarily. Some of these are tricky where there's a conclusion somewhere in the middle or at the beginning. Let's see, if you exercise, your self-esteem goes up. That's an if and applied then here. So if you exercise could be P, then your self-esteem goes up. That could be Q. So it's an if P then Q. If your self-esteem goes up, and implied then. So your self-esteem goes up. That was Q. Arrow. Everything is wonderful. That's a new statement, so I'm going to call that R. So, which would be my conclusion, if you exercise was P, then everything is wonderful. That is that new R. So if P then Q, if Q then R, conclusion if P then R, is that valid or invalid? So I'm going to look to see if I can find this in the table. Now, if I can't find anything in the table, then I would have to do my conditional statement and use the truth table. And that looks like it's valid. It would be this last argument. If P then Q, if Q then R, conclusion if P then R. And if you had to state a reason, it's valid because of transitive reasoning. So that would be the name of this particular type of argument. What if you have some premises, but you don't have a conclusion? And that's where that table is going to come in handy. Example 5, we're supposed to draw a valid conclusion. So what we're given is we're given premises. The first premise would be, if I study, then I will pass the class. So I study could be my P. I will pass the class. That would be Q. And then I studied. That would be P. I studied. Tenses don't matter. So this is a P, a Q, and a P. Symbolically, the first premise is if P, then Q. Second premise is P. I have my line. Therefore, what is my conclusion? If you look to the table, you'll see that a valid argument of this form would have the conclusion Q. So this is direct reasoning. Our conclusion is going to be Q. When you're asked to draw a valid conclusion, you have to include the conclusion word. So it's all of this with the 3 dots. Therefore, comma, I will pass the class. Okay, so this is where that table does come in handy. If you're supposed to draw a valid conclusion, set it up symbolically and then look at the table and see what the valid conclusion would be based on that first row of common or standard forms of valid arguments. Example 6, we're going to do the same thing. We're going to draw a valid conclusion. So we have these premises. First one is if all people lead, then no people follow. So all people lead would be my P. And again, I see that I have quantified statements, so I'm assuming this is going to give me an issue. So all people lead, then no people follow. That would be my Q. Okay, some people follow. That's not the same as Q, because Q is no people follow. But we do have to be careful. Recall our quantified argument. We have a no and we have a some. That's actually not Q. Some people follow is the negation of no people follow. When I set up my argument, it's going to be if P, then Q, and then some people follow would be a not Q. I need to find a conclusion. If I look to the table, I can see that the proper conclusion would be not P from the contrapositive reasoning. So in words, it would be therefore. All right, so P is all people lead. So if I was going to negate all, it goes some are not, or some people do not lead. That would be the conclusion from this quantified argument. I did this last example not because there's a lot of my lab problems from this section that are quantified, but because this is going to lead into the last section of this chapter. What we're going to do is we're going to look at a different way to determine whether quantified arguments are valid or invalid, besides switching them to symbolic form. And that's going to be by what we call Euler diagrams. So this is it for this section, and then we just have one more section, 3.8, coming up next.